Hi. So this problem is about logarithmic identities. So the reason we don't need to use a calculator is because we're given these two values with a base of b for the log of 4 and the log of 11. So we can break these problems down, and I'm going to do that one by one. We have information about the log base b of 11 and the log base b of 4. The log base b of 44 is nothing more than the log base b. Let me draw an equal sign actually. There we go. Equals the log base b of 4 times 11. Now, because of logarithms, and I'll get into this a little bit later if there's time, we can split this up into the log base b of 4 plus the log base b of 11. Now, if you haven't worked with logarithms before, this looks really weird. I've changed a product into a sum, and that seems to break the rules of math. But in the case of logarithms, a product inside becomes a sum outside of the logarithm operator. Let me just put these parentheses to make that a little clearer. Now we have these two values, and so I can just rewrite this as 0.712 plus 1.232, which I believe equals 1.944. So I believe that would be your answer for the first part. The second part, let me kind of draw an arrow down here. This is nothing more than the log base. I mean, they've already written it as 11 over 4. So I'm just going to start with that, of 11 over 4. So we can turn a product into a sum. We can turn a quotient into a difference, because dividing is nothing more than inverse multiplying. So this just becomes log base b of 11 minus log base b of 4. And in this case, the order matters, right? We have the 11 on top and the 4 on bottom. So 11 is being divided by 4, 11 minus 4. And again, we have the numbers for these. So let me just plug that in. Log base b of 11 is 1.232. Log base b of 4 is 0.712. My pen isn't writing. Oh, there we go. 712. And so the final answer of that, I'm just going to calculate that real quick. 1.232 minus 0.712. The answer I get for that is 0.520. So there's your answer for that section. Now the final part is a different log identity, not a product or a quotient, it's an exponent, right? So it turns out that the log base b of 11 to 4, or 11 raised to the 4th power, equals 4 times the log base b of 11. And again, we have this value, so that's just 4 times 1.232. And that is 4.928. So I'm going to leave this on the screen for just a sec. And then I am going to erase it all and briefly talk about why this occurs. I don't think I'll have time to get through all of it because I have a time limit of 5 minutes, but I'm going to leave this for like 5 more seconds and start erasing. So the reason we can do these logarithm identities has to do with what a logarithm is. I'm just going to talk while I'm erasing, so hang tight. A logarithm represents an exponent. It's the inverse function of the exponent. And the way we can describe the logarithm is it's the exponent needed to convert from one number to another. So like 2 cubed is 8, right? 2 raised to the 3 is 8. The exponent needed to get from 2 to 8 is 3. So the logarithm base 2 of 8 is 3. So 2 to the 3 equals 8. Log base 2 of 8 equals 3. So if I underline these in different colors, here's our base, here's our base, here's our exponent, and here's our result. And that's all I have time for.